Hello everybody and welcome here to a interesting tutorial on how you can use different approaches in Python to solve everyday problems in 3D. We have here a model of 88 cannon from the Second World War, and when you imagine that this model has, for example, so many parts, how it's assembled, and you have all the parts downloaded or purchased from TurboSquid or from CG Trader or whatever, it can be very hard and time consuming to put them all together step by step in Houdini. So the question is often, what problem do I actually face in the 3D world, and what tools and applications do I have to solve this? So for my example, I was needing a script that allows me to look in every subfolder of my model and assemble everything together accordingly to the structure of the file format. So here you can see the network, how all the pieces available from the download are assembled together and also transformed in 90 degrees because the model was shifted very much. And it had also no UVs applied. So the UV process is something very different, but in our case it was possible to use the labs UV auto UV, and therefore we get a simple and basic UV texture on our model. So you can see that everything here is then merged together and has some adjustments like normals and materials. So with Python in Houdini, you have access to a lot of different approaches to make your day-by-day work more easier. So you can see here that we have here the script of the Python, and the interesting fact of this programming language is that it also can be assembled with AI. So you don't need to know, for example, here the implemented libraries here, togehter and scroll text, file dialog, message box, and all this stuff, because with the day-by-day work with AI, you have a very large amount of data available from the internet. It will not work right from the beginning, but it's more or less a conversation and a back and forth of ideas and of problem-solving questions. So this script here, which is a STL loader and also OBJ loader, took about 2 days to assemble it to the version you will see now. So let's assemble and let's compile this script here, and you can see what it has created for us. I wanted a UI, a user interface. I wanted a progress bar to see when the files get loaded and imported into my Houdini scene. I wanted to access also different nodes below the geometry node, like the transform node, the AutoLab UV node, or when you need both, you can then pretty much select everything at once. And we can here specify the STL data, and the script is working the way that it's looking inside the folder and subfolders and searches for enumeration and for the alphabetical assemble of the scene name, of the file names, and then pipes them back into Houdini to load them step by step together, which saves, in my opinion, a lot of time. So you choose the folder here of your specified model, and it gives you a feedback of what STL files have been found within the folder structure. For me, this is very important to parallel look, okay, how many files do I have, what should Houdini import, and this is what the feedback window gives me so that I can be sure, okay, everything has been found accordingly to what's available. So in my case now, I don't want any additional function here, and I start the import now, and you can see here that it's loading the data into Houdini, and we end everything, and we have here a new model folder, and you can see after the import we have everything wired into this merge STL node and in the merge final node, and as you can see down below here, everything now gets imported accordingly to this what the software found. And this is something that should show you that the combination of AI and traditional ways in programming and in 3D can be a very advanced tool to make your day-by-day work easier and less frustrating. So don't think in terms of AI as a wonder tool that solves your laundry and everything, but more like an additional tool that has the power to combine data sets and information accordingly to your special issue. So as you can see, all the files have been assembled, but we have the problem that our 3D file is offset in the X direction here, and that's why we have the ability to choose also the transform node for the assembly. So you can see here that all the parts come together step by step here, right from the folder that we have adjusted and set up. And this is something that makes this tool so interesting and very helpful, especially when it comes to 3D printing or when it comes to the next step in the pipeline. And we can see here that our Python tool is pretty much able to add also the Autolabs UV node, and once this is done we can go and adjust here the activation of our transform nodes, and we also want everything together, and we start the import again. We need to access the folder. So probably imported the STL files are ready now for the further production and for the 3D printing or whatever you have in mind. So we can then here go to our merge node and also pipe this into, for example, Solaris to use it for further scene creation. So let's dive into the stage. And here you can see I have made a simple network which starts here with a scene import. The materials come from the Quixel bridge and are adjusted and compiled for the material X usage. And you can see here that the auto UV mapping turned out pretty well. It's not 100% perfect, but in terms of time and the speed of several productions, it can be used for previs or for shot mockouts and for the discussions where this asset should be in place. So I have here a dome light, and the dome light has an HDRI, and we use the Karma XPU and also the camera, which is here adjusted. Can then place everything, as you can see here, and make a render out of this setting with Karma XPU. And yeah, that is something I wanted to show you, that with the help of artificial intelligence you can do a lot of great programming back and forth and piping in different problems you face and the stage of what you want to achieve. And you can see here that our model assembles pretty well with the shader. Let's hit up the samples here, and yeah, something that helped me making this model here available for a project, and in that way I hope you learned something. And when you are interested in the little helper tool, hit me a comment. I'm happy to share to those who are in need of an STL or OBJ assembly loader. It will be also getting through a lot more iterations, and this is what makes the connection with AI so fun, because it's in the meantime so intelligent in brackets that it's knowing the data structure and the programming language also of Houdini, and can give you a lot of information and tips and tricks for your problem solving. So all in all, a very great tool. It was fun to develop this, and stay tuned for stuff that comes up in the future. And I hope you enjoyed this little tutorial here and the knowledge base, and I hope to see you soon. So hit like and comment and subscribe. Cheers.